Okay, let's do problem 105, construct binary tree from preorder and inorder traversal. So here we're given two integer arrays, preorder and inorder. So there are basically two ways of representing the same tree. So that's why each value of inorder also appears in preorder because they are the same tree. And this is quite important that preorder and inorder consist of unique values. So we have node 3, that means there won't be any other node 3. So first of all, let's quickly go through what preorder and then inorder are. Preorder is basically root to left to right, and inorder is left to root to right. So suppose we have example 1, 3, 9, 20, 15, 7, and then we can throw in like 4 and 10 as well. So to get a preorder representation of this tree, we get root, left, and right. So which is root, and then left and right. But before we get right, we're getting left, but here this is also root. So root, left, and right. So it has to be 3, 9, 4, and 10. And then we are getting right of the root, but we again follow root, left, and right. 20, 15, and 7. And then we get inorder, which is left, root, and right. And this as a whole is left of this root. And then when we get right, we have to get left, root, and right. So it will be left, root, and right. This as a whole is left of 3, and then we are getting right, but here we have to get left, root, and right as well. So now that we got this preorder inorder representation, we have to use them to create a tree. So because it's a recursive function, we need to create another method, say private tree node build, and then we have to call this recursively. But the question is, how are we going to approach this one? Well, we do know that preorder always starts with the root. So we have root here, and then there will be left and right. And when we look at corresponding value in inorder, because by definition, root is in the middle, everything on the left is left subtree, everything on the right is right subtree. So we do know that 4, 9, and 10 will be somewhere here, 15, 20, and 7 will be somewhere here. And we construct this tree one by one. And to do that, we have to traverse preorder one by one as well. So our initial point of preorder was here, but after creating this node, the next pointer, the pointer moves one. But the question is, yes, we got the root. How can we get the corresponding root in inorder? Well, because they said they only have unique values, we can use hash map. We can create a hash map of inorder where key represents these numbers will be key of the hash map and the values will be indices. So it will look something like this. Kind of running out of space here, but it's fine. So we got 3 and then we got 3. So we do know that everything on the left is left subtree of 3, and everything on the right is right subtree of 3. And then now that our pointer is pointing to 9, this will be the root, and then this will be left, and then this will be right of this 9 here. But it's not really correct just to assume that right that it's going to be right next to the root. The reason is if we have multiple subtrees here like this, there will be multiple numbers beside 3. So the right should actually be here. So basically what this left and right represents is the boundary of the tree. So because otherwise we don't really know when to stop, but we need to stop before 3. Likewise, when we look at the right side, this will be the left and then this will be the right. But what's the left? Left is I'm going to remove this one. So left is always, so we get the index here, is always index plus 1, and then for this one it's always index minus 1. And initially we had 3. In that case this is left and then this is right. So that gives us the boundary of a tree. So we constantly repeat this until we create a tree. But it's not like the best explanation, but as we go through the questions, it's gonna make much more sense. But before we call this build, we can do some of the edge cases. So each value of Inorder also appears in Preorder. So that basically means that the length must be equal. So if Preorder.length is not equal to Inorder.length, we can just return null. But there could be a couple more edge cases, like if Preorder equals null or Inorder equals null. So we can do early exit. And then we need to create a hash map before we do anything. So because hash map needs to be accessed in this build method, so it would be a good idea to create a hash map here. So it will be Inorder index. And then we have this Preorder. That means we need to, because we need to like increment the count of the Preorder, we need to put Preorder as an input for build. And counter should be accessed out in both functions. So we can say private, that would be Preorder index. It's gonna be 0 initially, and we need to create hash map now. So quite simple. For int I equals 0, I is less than Inorder.length, I plus plus. We do in index, in order index is put. So we are putting the value which is Inorder dot I, and then I. So that would be H cases. That would be hash map. And that's this is when the recursion takes place. By recursion, this will return true. So we'll return build. So we do know that we need preorder. And we've already established the left and right pointer should be beginning and end of Inorder. So beginning is 0, and it will be Inorder.length -1. So we do need int array of preorder, and then int L, and then int R. So first of all, we are going to get the value of preorder. So it will be int root val is equal to preorder dot preorder index. Actually, it's a bit too long. Preorder. Okay, let's do this. No, it is so long. Pre-index. Terrible naming convention. And then after moving it, we can increment it. So we got the value of 3. Now we are going to create a tree node. So it will be tree node root is equal to new tree node of root file. Okay, so now we have to find the position of the corresponding root value. So it would be int center, int mid, because which is always in the middle, and it will be Inorder index dot get root file. And we've said that the route boundary for the left subtree would be index -1, so it should be mid -1. So we need to recursively call one on the left and then one on the right. And let's see, we need to put in preorder. And then we need to put for L remains the same, well, at least for this one. And then the right value is whatever mid -1. And then it will be preorder, the opposite of left, so it should be mid +1, and then right. All right, so let's do some simulation. So we have preorder, so it's N9 now, and then we put in mid -1, which is index of 2 here, and we are looking at 9. So we create a node of 9. And then we get the index of 9, which is 1. And then we are putting 0 here. And then we are putting 2 here. So left is 0, and then this is 0 as well. So that would be 0 and 0. Coming in, and then we get the root file. So at this point pointer would be at 4. So we create a node of 4. And we do know that it should stop at this point, but we are going to still calls the method. So we are putting L is 0, and then right was 0 as well, mid is 0, but we are doing 0 minus 1. So when right is smaller than left, that's when we know that there isn't any node. We just return null. So it will return null here. Okay, so I guess that's it. Let's run the test. Oh my days, what are we doing? We need to return root. Okay, let's submit. Okay, that's it.